We're back with another edition of Statistics in Sweats. Hi, everyone. Couple things, just one thing, really, I wanted to say before we jump into the topic this week, which is sample spaces, is we are no longer just doing completion. I was doing completion, but we're no longer just focusing on you getting work done. What we're doing now is if you submit the work, we're going to give you an 85%. Just do every single thing to the best of your ability, 85%. Boom, done. If it's perfect, of course you're going to get a 100. But if it's not perfect, what I'm going to do is I'm going to give you feedback. You will see the feedback. If you improve on it, you can get a 90 if it's like pretty good improvements, or you can get that 100 if you make, exact improvements and do what you need to do. So that's how grading is going to work from this point forward. I'm going to start entering grades in MMS for this new quarter probably next week because I want to give you time to get your stuff done. Okay, great. Like I said, this week is sample spaces. So a sample space that I can't ask you to do on Google Classroom is called a tree diagram. So, for example, if I was flipping a coin twice, okay? If I'm flipping a coin twice, I either get heads or tails. But that's my first event. So my first event is heads, tails. So I can either get heads and then get heads or tails, or I can either get tails and get heads and tails. And this is like the most basic tree that it can get. Like you can do 4 coins and flip them, and then each of these would have 2 coming off of them, and each of those would have 2 coming off of them. This is a tree diagram. I'm not going to ask you to do it, because unless you took a picture and then submitted the picture and imported it in a document, and it's just a mess. So what I'm going to do is I'm going to show you kind of a short version of giving 4 standovers. Anyway, so sorry. I'm going to show you a short version of how to create a sample space and how to use that sample space. So let's do it. Let's flip a coin 3 times. So these are all the different ways you can flip a coin 3 times. And I'm not going to write out heads, heads, heads. I'm just going to do H, H, H. Heads, heads, heads. Then I will do heads, heads, tails. Heads, tails, heads. Heads, tails, tails. Yeah, that makes sense. And then I'm going to do tails, heads, heads. Tails, heads, tails. Tails, tails, heads. And tails, tails, tails. So there's 8 total different ways that we can flip a coin and get different events, okay? For the record, in case you were wondering, tails, heads, tails, since there's 2 tails, does count as a different event than tails, tails, heads, which is also 2 tails. They are different events because they happen at different times. Whatever. So there's 8 total. And to figure out if you have enough, we know there's a 1 out of 2 chance of getting heads, right? So there's 2 different things that could happen. So if we're doing 2, 3 times 2 times 2 times 2 is 8. So you should get 8. That's how to figure that one out. Okay, great. So that's just the sample space. So one of your assignments is just to write out all these letters, put commas in between or, bigger spaces in between so I can see that you have all 8 events. But the second one is going to be taking those same sample spaces and answering probability questions. So I'm going to say, what's the probability of getting heads at least once? So this does not mean you get heads once. It means at least once, which is once, twice, or 3 times. So I'm going to look at what I have. And remember, there's 8, so it's going to be over 8. How many of these have heads at least once? 1, 2, 3, 4, 5, 6, 7. So I have a 7 out of 8 chance of getting heads at least once. Boom, you're done. 7 out of 10, you're done. That's it. That's it. Or I could ask you a question like, what's the probability of getting the same result all 3 times? And that's going to require you to look for something a little bit different, right? You need to look for 3 of the same. Well, that's 3 of the same. That's 3 of the same. So it's 2 over 8, or if you're fancy and want to simplify, 1/4. So this is one of the more basic ones. It might be on your assignment. You never know. Wow, it's important to watch these videos. So that's like one example. Let's do another one. If I said pick 2 cards and record the suit, right? So there's hearts, diamonds, spades, and clubs. Hearts, diamonds, spades, and clubs. So I'm going to be using these letters. So different things can happen, right? And we should expect 16 results because there's 4 options for the first, 4 options for the second. 4 times 4 is 16. So just to kind of let you know that you're doing the right thing and not missing anything. So I could get hearts, hearts, heart, diamond, heart, spade, heart, club. I could get diamond, heart, diamond, 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 spade, diamond, club. And when you kind of write it like this, you'll see a pattern happen, and it'll help you figure out if you've missed something. And then I'm going to do spade, heart, spade, diamond, spade, 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 club, club, heart, club, diamond, club, spade, club, club. So those are my 16 different possibilities if I just pulled 2 cards out of a deck and I only cared about the suit. So what is the possibility, or probability I should say, that I get 2 black cards? So it's important to know which ones are black. Spade and club. Cool. So I'm going to look for 2 spades, 2 clubs, or a spade and a club. And it's going to be out of 16. So automatically these 2 rows aren't going to be what I need since hearts and diamonds are red. So let's look here. 1, 2, 3, 4. 4 out of 16, which when we simplify is 1/4. Cool. Another question I could ask is what's the probability that I grab at least one that's red? So remember, the red cards are going to be hearts and diamonds. And let's take a look. At least 1 red. That doesn't mean there can't be 2 reds. It just means at least 1 red. Remember, since there's 16 of our little packages, there's going to be 16 total. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, skip, skip, 11, 12, skip, skip. 12. And that, when I simplify, is 3/4. And if you think about it, this is really the opposite of this question. Because if there's 2 black cards, then none of them are red, which means it's the opposite of at least 1 red. Great, so that's why they kind of match up like that. Last one I want to go over is honestly my favorite because I love just the probability of rolling dice. I don't know why. I just really love rolling die. There is a game called Shut the Box, and I wish I had it, and I wish I had it in my room and you guys would play it, but you're at home, whatever. So basically, you have 10 numbers, 1 through 10, on this game, and you roll the dice, and you throw them, and if I rolled in 8, I could either put down the 8, I could put down a 1 and a 7, a 2 and a 6, a 5 and a 3. I can't do 4 and 4 because there's only 1 4. But if I rolled an 8, let's say I put down the 8, great. Now when I roll again, whatever I roll, I can no longer put down the 8. So if I rolled a 12, I can't do 8 and 4 because 8's already down. I would have to do 10 and 2. Whatever. It doesn't matter. It's just a really fun game that I decided to tell you about. Rolling dice. So the way that you can do it on the document, this is the way that I'm going to show you how to do it. We can get a 1, then a 1, 1, then a 2, 1, then a 3, 1, then a 4, 1, then a 5, 1, then a 6, and then so on and so forth. I'll put that back up, but I want to show you another way that some people do this. So, I'm going to make a bunch of little boxes. 1, 2, 3, 5. 1, 2, 3, 4, 5. So if we were at school, I'd be showing you this way to do it. And I think it's a nicer way to look at it. Okay? Because 1 and 1, that means my roll is a 2. 1 and 2, my roll is a 3. 4, 5, 6, 7. 1 and 2, I get 3. That's a sad looking 3. And I'm just going to kind of quickly fill this out. If you want to stop and take a picture of this, it's going to help you a lot with the next set of questions I'm about to ask. Kirk, what time is it? 4? All right. So if we were at school, this is the way I would do it. Where I would make you, it looks like a multiplication table, but it's for addition. And that way I'd be like, oh, what's the probability of rolling an 8? And you could look here, 1, 2, 3, 4, 5, out of 36, boom, done. But unfortunately, this would be impossible to do unless you made a table on the Google Doc, which would be phenomenal, but it's a lot of work. So I'm going to quickly write what we need. Let's go 1 and a 1, 1 and a 2, 1 and a 3, 1 and a 4, 1 and a 5, 1 and a 6, 2 and 1, 2 and 2, 2 and 3, 2 and 4, 2 and 5, 2 and 6, 3 and 1, 3 and 2, 3 and 3, 3 and 4, 3 and 5, 3 and 6. Please know that this doesn't say 11, 12, 13, 14, 15. Please know that it doesn't say that. Right, 4 of them. 3, 4 and 4, 4 and 5, 4 and 6, 5 and 1, 5 and 2, 5 and 3. Whoops. I was trying to do 2 columns at the same time, and my brain was like, nope. 5 and 4, 5 and 5, 5 and 6, 6 and 1, 6 and 2, 6 and 3, 6 and 4, 6 and 5, 6 and 6. So here's the sample space. Yes, again, it doesn't say 11, it says 1 and 1. This doesn't say 21, it says 2 and then 1. This doesn't say 31, it says 3 and then 1. This is me trying to accommodate for the craziness of what we're doing right now. So, take that in consideration. So there's 36 total, because there's 6 chances, 6 ways to roll the first die, and then 6 ways to roll the second die. 6 times 6 is 36. You should have 36 things. And I wrote them all out just for you. So you might get a question that's like, what's the probability of rolling a 7? Something you should know if you're ever going to play a game that involves rolling dice is that 7 is the most common roll. It's the most probable roll, I should say. And if I look at this, I'm going to circle. I'm going to circle all the ways that we can get 7. And it's really nice when you lay out your sample space like this, because 7 goes right down the middle, right? Like 5 and 1 is 6, 4 and 2 is 6, 3 and 3 is 6. And you kind of see that the totals go in a diagonal. So I have 1, 2, 3, 4, 5, 6 ways to roll 7. Out of 36 possible ways to roll the die, when I simplify, I get 1 out of 6. Sweet. That's it. It's as simple as that. But then I could say, what's the probability of rolling a double? And by double, I mean like 1 and 1, 2 and 2, 3 and 3, 4 and 4. Well, let's look. 1 and 1, 2 and 2, 3 and 3, 4 and 4, 5 and 5, 6 and 6. Those are our doubles. and I box them so that it doesn't get too confusing. So I have 6 boxes out of 36 ways. Oh my god, it's 1/6 again. And it's just like that. Next week, we're going to kick it up quite a bit because next week we're going to introduce two-way tables, and I'm going to have to figure out a Google Doc way of making that easy peasy. But that's next week's problem. This week's problem, I hope, isn't too overwhelming. If you have any questions, please reach out to me. We can set up a Google Meet. We can do whatever you need. But that is all I have for you this week, and it's nice, short, and sweet. Keep an eye out for feedback starting on assignments due on Friday. So older things, I really want to dedicate my time to your grades, really, honestly. So starting on assignments due on Friday, which will be these 2 assignments, and then the quiz that I'm going to post on Thursday, I'm going to be giving feedback. Even if it's, like, if you did it perfectly, I'll be like, good job, and you don't have to resubmit it. But if you didn't do it perfectly, I'm going to say, hey, redo this one, redo this one, redo this one. And then if you resubmit and it's perfect, you'll get your 100%. I'm done rambling. Thank you for your attention this week. I hope that it's nice and easy for you. And if it's not, let me know. See you guys. Bye.